Hello guys, my name is Bob and welcome to Let's Practice Integration episode 1. So in this video, I'm going to work out some very basic integration problems, and I'm sure that right now in this current situation, students you guys want to do a little bit more practice to prepare for your upcoming tests or exams, especially for people who have like national exams this year and they need some practice. All right, and I understand that my channel, most of the integration problems which I've uploaded are usually quite advanced integration problems, so I was thinking maybe I should do some very basic integration problems, all right, so that you guys can actually follow along and practice also as well. So let's get started. Okay, so let's start off with the first question, which is the indefinite integral. So this is what we call the indefinite integral of x cubed, all right, dx. So how do we perform this? It's just basically add power by 1. At the same time, we divide this over the power, which is 3 plus 1, and then don't forget plus c, which is a constant, and then this would be equivalent to x to the power of 4 over 4 plus c. All right, and so this is the first answer of the question, the integration of x cubed dx. The next question will be to integrate 2 sine x dx. All right, so in this scenario we can put the constant out of the integral sign, so that will be 2 integral of sine x. Okay, and then when we integrate sine x, it just basically it's basically just negative cosine x, so it becomes 2 times negative cosine x plus c, which is equivalent to negative 2 cosine x plus c. All right, so this is question number 2. Moving on to question number 3, we have the integral of e to the power of x plus x, the whole thing dx. So for this kind of question, we can actually split this integral up into 2 integrals. So the first integral being the integral of e to the power of x dx, plus the second integral will be the integral of x dx. So let's work out the first integral. So for the first integral itself, it's just basically, all right, e to the power of x, whereas for the second integral, it's just basically x to the power of 1. We add 1 to the power and then divided by 1 plus 1 and then plus c, and in which we have the final answer would be e to the power of x plus x squared over 2 plus c. Noting that when you integrate e to the power of x, is just basically equivalent to itself. All right, and another note before I forget to remind you guys, every time when you perform the integration, all right, indefinite integral, they must always put a plus constant behind, because this whole equation itself is a general equation. All right, moving on to the next problem, which is to integrate half x, right, minus 2 over square root of x minus 3 dx. All right, so the first thing that we can do, to solve this problem is to actually split this up into 3 different integrals. The first integral being integration of half x, while the second integral being the integral of 2 over square root of x dx, while the last integral being the integral of 3 dx. And then we work out the problems one by one. All right, for the first integral, the constant itself, we can bring it out of the integral sign, so we we will get half, okay, integral x dx, okay, and then the second integral is we also bring the constant out of the integral sign, so that would be 2 integral of 1 over square root of x dx. And last but not least, the third integral should be an easy one, but we will just leave it as it is for now. Okay, after which we will start working out each of the integrals. Alright, so for the first integral itself, we know that the integration of x is just basically as per what we solved previously, is actually x squared over 2. So we have half, and then we have x squared over 2. Right, and then the second integral is a little bit different, because firstly you have to convert this whole equation into an indices. So basically 1 over square root of x is equivalent to x to the power of negative half, right? And then we can work out the integration, okay, of this term. So the integral of x to the power of negative half is just simply x to the power of negative half plus 1 over negative half plus 1. And then last but not least, the third integral, every time we integrate a constant itself, okay, we just need to add a x behind. So in which, okay, don't forget the plus c is very important. So in which we have the final answer being half times half x squared, it becomes x squared over 4 plus, well, this whole thing itself is just basically wow, okay, let's just simplify it. This whole thing itself, this denominator is basically half, right? And then the numerator is just x to the power of half, okay, in which, okay, the final answer is actually negative 4 x to the power of half, all right, which can be expressed as the square root of x. And then last but not least, we have minus 3x plus c. And this is our final answer to the question number 4, which is the integration of half x minus 2 over square root of x minus 3 dx. Alright, so right now we're going to pretty much erase the whole thing, and we will try and perform some other kinds of integration. Okay, moving on to the fifth integration problems, we have the trigo ones. All right, let's do some trigonometry questions. All right, first thing, we have the integration of sine x minus 3 dx. So for this kind of problems, we can split the integral or the integration up into two different integrations. The first one being the integral of sine x dx, subtracting away the integral of 3 dx. And then we can continue to perform the integration. So the integral of the indefinite integral of sine x dx gives us negative cosine x, okay, and then minus the integration of 3 dx gives us a minus 3x plus c. Alright, don't forget the constant c, okay, in the indefinite integral problems is very important because it represents a kind of general solution to the integral. Right. Okay, moving on to next, we have one very important, not say very important, but one very common question. All right, integration of sine 3x. All right, so this is equivalent to, first thing first, we need to know that my fx, okay, we let fx being the original function itself be 3x, and then we know that the differentiated form of the function itself is just basically equals to 3, right? Because there's a fx inside here. So which means, okay, you need to have first thing first, a 3 in front, all right, and f prime x in front, right? Okay, so in this case we have 3 sine 3x, and then we have 1/3 in front, all right, and then this will be, okay, this will be the equation, and then moving on, which we can straight away perform the integration, in which it gives us the final answer, which is actually negative 1/3, okay, cosine 3x plus c. All right, so why is this the case? Is because when you differentiate, okay, let fx be cosine 3x, and then if you were to differentiate cosine 3x, you will actually get negative sine 3x times 3, okay, which is equivalent to negative 3 sine 3x. All right, so basically how do you actually check is that you can perform differentiation, and then you will get this answer. All right, so that is the integration of sine 3x. Okay, moving on, we have, all right, we have the next problem, which is integrate 3x cosine, okay, 2x squared dx. Okay, so it's pretty much the same thing. We need to ask ourselves, so this is the, kind of like the differentiated form, correct? And then what about the integrated form? So what about fx itself? So we know that fx is probably something to do with sine 2x squared, right? And then if you were to differentiate with respect to x, it will give you cosine 2x squared, and then you differentiate the inner portion, which is 2x squared. So that gives you cosine 2x squared, well, basically this should be a cube, right? It should be a cube? Yeah, no. So this should be like, you'll get something like a 4x or something like that. But you have only 3x. You need to convert this into 4x first, and then you can integrate. So how do you go about doing it is that you sort of like multiply, all right? You multiply kind of 3/4, right? 3/4, all right? And then you have 4x cosine 2x squared dx, okay, in which right now this whole thing is the f prime x, all right? And then when you integrate this f prime x, you will get back fx. So in this case, you'll get back 3/4 sine 2x squared, right, plus c. And this is the final answer to the integration problems of the integral of 3x cosine 2x squared dx. I'm sure that these two problems are a little bit more complex, because basically you need to understand about the concepts of this kind of way of doing the integration problems, all right? Okay, and then last but not least, we're going to tackle just one exponential problem. I know that previously we know that the integration of e to the power x is just itself, but what if we have the integration of e to the power of, okay, e to the power of negative 3x plus 5 dx. So how do you go about doing it? So basically we use, okay, this formula in which, okay, the integral of e to the power of ax plus b dx is equivalent to 1/a e to the power of ax plus b plus c. So in this case, following this formula, we take a to be negative 3, b is 5, in which we just need to copy the formula, so it becomes 1 over the negative 3 e to the power of negative 3x plus 5 plus c. And then the final answer is just basically negative 1 over 3 e to the power of negative 3x plus 5 plus c. Okay, and this is the final answer to the integration problem of e to the power of negative 3x plus 5. Let's do one more exponential problem. All right, pretty sure that using this formula. All right, okay, so using this very important formula, okay, to solve, okay, another integration problems involving exponential. So we have the integral e to the power of half x, okay, plus 2 dx. Same thing, we use this formula, okay, and then we let a be equals to half, and then b equals to 2, and then we now have 1 over half e to the power of half x plus 2 plus c. And this is equivalent to when you take 1 divided by 0.5 gives you 2 e to the power of half x plus 2 plus c. And this is my final answer to the integration of e to the power of half x plus 2. Alright, so don't forget the plus constant plus c, which represents plus constant, okay, when you perform the indefinite integral. Alright, that's all for the episode Let's Practice Integration today. I hope that you guys can spend a little bit of time with me together performing some integration problems while you're quarantined. All right, especially for those people who are preparing for the exams. I hope that this a little bit of problems help you to kind of like do a little bit of practice. All right, if you guys do like this video, press the like button, and don't forget to subscribe, and don't forget to comment what kind of integration problems would you like to see next, and how I can actually improve on this kind of integration problems video. All right, thank you guys for watching. My name is Bob, and I'm signing off from here, and see you in the next episode.